Hi friends, in the last class we are discussed about the strength of material. In the strength of material, first chapter is completed. So today we are discussing about the fluid mechanics subject. In the fluid mechanics subject we have so many chapters. In that first one is properties of fluid and introduction to the subject. In this chapter we are going to learn what are the basic definitions of the subject and what are the units for each definitions we have and what are the dimensions formulas. So in the introduction, first we have the ideal fluid and real fluid. What is ideal fluid and what is real fluid? So in the ideal fluid, a fluid is said to be ideal if it is assumed to be both incompressible and non-viscous. So it is called ideal fluid. The bulk modulus of the ideal fluid is infinite. Next one is, in the ideal fluid has no surface tension. So the surface tension for the ideal fluid is 0. Ideal fluid are imaginary and do not exist in nature. Next one is real fluid. What is real fluid? The real fluid have the viscosity and infinite compressibility and surface tension. Next one, basic definition of what is the specific weight and or specific density. Specific weight also called specific density. Weight by volume, m into g by v, that is equal to rho into g. The specific weight of the water equal to 9.81 kilonewton per meter cube or 9810 newton per meter cube. Specific gravity. What is specific gravity? The density of the fluid by density of the standard fluid. What is the standard fluid? We can take as water. Specific gravity of the water is 1 at 4 degrees centigrade, and for the mercury it is 13.6. Next one is Newton's law of viscosity. What is Newton's law of viscosity? Here shear stress equal to mu into du by dy. So here tau equal to shear stress, we know that, mu equal to coefficient of viscosity or coefficient of dynamic viscosity, we can say that. Here it is coefficient of dynamic viscosity. Du by dy, that is total, this part total equal to velocity gradient. Or in the examination, some examination he will give the u value, then what we have to do? If he is given u value, then we have to differentiate it. Or he will give the velocity gradient value, then we can put the value of, in the place of du by dy, we can put the velocity gradient value. So in the reverse case, he will give the shear stress and velocity gradient, then find the coefficient of viscosity. Then you can find out from this equation. d theta by dt equal to rate of angular deformation. Okay, he will give the relations in this way, d theta by dt equal to du by dy. Then we can find what we want from this equation. For the Newtonian fluid, the coefficient of viscosity remains constant. Okay, it does not change, it is constant. Next one is kinematic viscosity or dynamic viscosity. For the kinematic viscosity, we can denote with the symbol rho, and dynamic viscosity it is mu. What is dynamic viscosity and what is kinematic viscosity? Dynamic viscosity and kinematic viscosity. So dynamic viscosity, what is the dimensions formula is m into L power minus 1 and T power minus 1. SI units of dynamic viscosity are Pascal second or Newton second per meter square. CGS units equal to Dyn second per centimeter square. 1 poise equal to 0.1 Newton second per meter square. So these four are very very important because of in the previous examination these 4 points are like a 4 questions. Okay, this is very very important for us. Next one is kinematic viscosity. What is the kinematic viscosity? Dynamic viscosity by mass density. Dynamic viscosity by mass density. So what is the dimensions formula? Dimensions formula is L square into T power minus 1. SI units are m square by or meter square by second. CGS units equal to centimeter square per second or stroke. Centimeter square per second also known as stroke. 1 stroke equal to 10 power minus 4 meter square per second. See, next one is viscosity. Viscosity of liquid is due to cohesion. Viscosity of liquid is, what is the reason behind it? It is due to cohesion. And for the gases it is due to molecular movement of transfer. Molecular movement of transfer. Viscosity of liquid decreases with temperature, whereas viscosity of gases increases with increase in temperature. Okay, this is also previous year exam question. Next one is, what is the pressure inside a drop, or what is the surface tension, and for the bubble and for the jet. Pressure inside the drop, what is the formula? 4 sigma by D. Pressure inside the bubble, pressure inside the bubble, nothing but soap bubble, you can say that soap bubble equal to 8 sigma by D. Pressure inside the jet, what is the formula? P equal to 2 sigma by D. Here sigma equal to surface tension, sigma equal to surface tension, and D equal to dia of the drop, and P equal to gauge pressure. So here see how to remember these 3 formulas. See, first one is pressure inside the drop, 4 sigma by D. Next one is pressure inside the soap bubble, it is bubble or soap bubble, 8 sigma by D. So how to remember the 8 sigma by D? Bubbles, how we can see the shapes in the circular shapes. Okay, if you join these 2 bubbles you will get the like a 8. So we can remember in this way 8 sigma by D. When the bubble is come, then we can say that 8 sigma by D. Next one is surface tension is force per unit length. What is the units of surface tension? Is Newton per meter. This is very very important because of these units are directly asked in the examination. For the water air interface at 20 degrees centigrade, its value is 0.0736 Newton per meter. Surface tension is due to cohesion only, not due to adhesion. It is due to only cohesion only. At the critical point, the liquid vapor state are same, thus surface tension equal to 0. This is about the short formulas of the introduction of the FM subject. Next one, part 2 short notes will continue in the next class. Okay, thank you.